Hello guys, welcome to the channel, and today we're going to be solving this limit here. Okay, so let's evaluate this one here, guys. So x to the x to the x, right? So let's say here, applying this one 0 to the from the right here, so we're going to have this is 0 to the 0. This is the type of indetermination, right? So to solve this, I'm going to say that x to the x, I can write this as a to the ln of x to the x, right? Since this one here goes with this, we're gonna get back to this, so this is equal to a to the this one comes here, x ln of x, right? So given this, applying here, we're gonna have then that limit approaching 0 to the from the right, so this is going to be equals to limit of e to the x ln of x, right? So and this one can be written as x, sorry, we can write this limit now as let me erase this. So this is actually e to the limit x tends to 0 of ln of x here. Okay, so now let's evaluate this limit here. So we're gonna have that limit so this is going to be, if we apply this here, the 0, so we're gonna have to find the indetermination form. We're gonna have that this is 0 times ln of 0. This is 0 times infinite, right? And this one here is also an indetermination, so we're not going to work with this. Let's make some transformations here. So we're going to have that this is limit as x goes to 0 to the from the right. So we're going to have then that this is, I'm going to say, well, this one here, and I'm going to say this is a limit 0 plus, I'm going to say this is ln of x 1 over x, right? Because this is the same thing. If we apply now the indetermination here, we're going to say that this is equals to ln of 0, right, which is infinite, and 1 over 0, which is infinite. So this is infinite over infinite. So from here, we know that we can apply the L'Hopital rule, right? L'Hopital rule. So we're going to go and get this one here. So this limit here, x ln of x equals ln of x over 1 over x. So applying L'Hopital here, we're going to differentiate the numerator and differentiate the denominator. So we're going to have here 1 over x differentiated here. So we're going to have now that this is then going to be equals to limit as x goes to 0 from the right. So this is 1 over x, and this is 1 over x squared, and negative what the differentiator of this. So this one here would be just 1, oh sorry, we have to write this, okay, right? So from here we're gonna have that this is let me say here 1 over x, right, negative times x squared, right? So this goes with this, and I'm gonna have, sorry, this is not appropriate to do, right, because we are solving a limit here. So this is gonna be limit as x goes to 0 plus here, and then this is gonna be 1 over x negative here times x squared, and then this one goes with this, and then we have a limit as x goes to 0 plus here, and then we can put this negative here if we want. So we're gonna have then x here, right? So and applying here, we're gonna have negative 1 times what, 0, and this is 0. So this limit here is 0. So we have then that therefore limit as x goes to 0 plus here of x ln of x is equal to 0. But let's get back here where we made our we started to work on this one. So we're gonna then write that a limit of when x goes to 0 plus here of x to the x equals to a limit. This is what we said, right? 0 plus here. This is e to the we said ln of x to the x, and then this became limit as x goes to 0 plus, and this became e to the okay, we can write this one here. So I'm just talking too much instead of writing. So now, and then we say that this is equals to a limit as x goes to plus here of e to, we said actually that this one here now became, let me erase this too. So this is, we said that this was e to the limit of this one here, right? X ln of x, and then I'm just simplifying every step we did here. So, and then we had this limit as x goes to, we can stop here, right? We can stop here and say that this one here, this is what we got here, guys. So this limit is 0. So if this limit is 0, it means that this is e to the 0, which is 1. So at the end we have then that the limit as x goes to 0, x to the x is equal 1. Okay, guys, so this is the limit here. Thank you very much for watching. See you next video. Bye bye.